Hi, in this video we're going to look at perpendicular lines. So here we've got the equation y equals 2x and we want a line perpendicular to it. Perpendicular just means at right angles. So if I drew this straight line, you can see it cuts my original line at 90 degrees. So this line had the equation y equals minus a half x. Let's see that idea again. So here I've got an equation y equals a third x. If I drew a perpendicular line, you can kind of see it looks something like this, where these two cut at right angles, and this has equation y equals minus 3x. What we're going to look at here is how we go from one gradient to a perpendicular gradient. So the key rule is you take what's called a negative reciprocal. So the reciprocal means you basically flip it upside down as a fraction, or write it as 1 over. The negative part just means you toggle the minus sign. If there's a plus, you add a minus, and vice versa. So if I've got a gradient of 2, to find the perpendicular gradient, first you write it as 1 over 2, and then add a minus sign. And that's basically all there is to it. So in minus 4, we can write it as 1 over minus 4, and add a minus sign. And here if you've got two minuses, they're going to cancel out. So in my head what you always do, I just toggle the minus sign. If there isn't one, you add a minus sign. If there already is a minus sign, then you just take it away. It's that straightforward. For fractions, this set looks a bit different. In fact, it looks a bit easier in my personal opinion. All you need to do for fractions is flip that fraction upside down. So the perpendicular gradient of this will be minus 4 over 3. So for minus 7 over 5, we'll go to 5 over 7. We had a minus here, so we don't have one here. Minus a fifth would go to 5 over 1, which is just 5. And lastly, if we particular mean, you might have a gradient of 3.5. In order to find the negative reciprocal of that, you must first write it as a top heavy fraction. So this is 7 over 2. Then flipping that out of the minus gives me minus 2/7. Okay, let's see questions where we need to use that. So we're going to find the equation of a line perpendicular to this, and it goes through the point 0, 4. So this has a gradient of 3. So for the perpendicular gradient, we have to negative reciprocal, so write it as 1 over, and we add the minus sign. So this equation for this other line will be minus a third x plus c. And we know it goes through 0, 4. If the x-coordinate's ever 0, then this must have been the y-cut. So therefore the equation of this line is minus a third x plus 4. Okay, let's see that idea again. So perpendicular line to this, which goes through this point here. First step, we're going to identify a gradient. Here m is minus 2. Therefore our perpendicular gradient will be 1 over that. And we had a minus sign, so we're going to get rid of it. So the equation of this new line, or the perpendicular line, is going to be y equals a half x plus c. We can now work out the plus c just by plugging this coordinate in here and then solving the equation. Doing that, we can see that these two terms give you 1, so therefore c is 6. So therefore the equation of my perpendicular line was y equals a half x plus 6. Okay, same idea again, this time with a fractional gradient. So if my initial gradient is 2/3, then my perpendicular gradient will be that flipped upside down, and we need to add a minus sign because this was positive. Then it's the exact same idea. Let's write that down. Y equals minus 3 over 2x plus c. And we're now going to plug in this coordinate to work out what c is. This is slightly more awkward because we have a fractional gradient, but it doesn't change too much. So we do minus 3 over 2 times 6 is going to give you minus 9. Therefore c must be 14. And then we're done. We have the equation of this line is going to be y equals minus 3 over 2x plus 14. Okay, let's see how other ways you can spin this question. So typical way is not giving you the gradient of the initial line, you have to work it out. So here you want to equation of a line perpendicular to this line AB and has to pass through the point B. So on my sketch on this graph, it looks something like that. First step, we need to work out the gradient of this line here. So here I can just use the formula to work out the gradient, yt minus y1 over xt minus x1. y2 is 0, y1 is minus 3, and x2 and x1 are 6 and 0. So solving this, we've got 3 over 6, therefore this gradient is a half. Now we can work out this gradient with the negative reciprocal of that, so a half goes to 2, and we add a minus sign. So we can now write that down in the form of y equals mx plus c. To work out plus c, we need a point that this line goes through, and we're told it goes through the coordinate 6, 0. So plugging that in will allow us to work out what c is, and it can be seen that c is 12. So therefore the equation of this line is going to be y equals minus 2x plus 12. Okay, you've made it slightly more awkward by sort of giving you more weird shapes like triangles, or in this case a rectangle. So rectangles, one key thing we know is that all these corners are 90 degrees. Because they're all 90 degrees, that means each line and the one next to it are always going to be perpendicular. So we're asked to work out this coordinate q here. The way we're going to do this is we're first going to find the gradient of this line. Okay, you only find the gradient of a line if you have 2 points on them. Once you have the gradient of this line, I can then work out the gradient of this line. So let's get started. So let's label our coordinates x1, y1, and x2 and y2. And we're going to work out the gradient. So y2 minus y1 over x2 minus x1. That gives me 6 over minus 3, which is just minus 2. So this line has a gradient of minus 2. So therefore this line must have a gradient of a half, because that's a negative reciprocal of minus 2. So we can now write down the equation of this line. So again, if you're not sure where to start with questions, just working out anything you can, like a relevant gradient, and then go from there. For this question, we want the equation of this line, which we can work out because we know it goes through point C. We know it has to go through 7, 6. So let's plug that in order to work out what C is. So x is 7 and y is 6. Okay, half of 7 is going to be 3.5, or 7 over 2. We can now work out C because 6 is just 12 over 2. So therefore C is going to be 5 over 2. Okay, combining those together, we now have the equation of this line is y is a half x plus 5 over 2. So let's see what we can do with that. So we need to find the coordinate of q, and we see here q is on this line, but it's actually just the y-intercept. And we know here the y-intercept, we're already told, is just 5 over 2. So that must have been the value of q. Okay, let's just see one more idea like this. So here again we've got 2 lines. They are perpendicular to one another, and we have the equation of this first line. So first thing we're asked to do is find the equation of line L, which is this line down here. Okay, let's get started. So y equals mx plus c. We want the perpendicular gradient for minus 3 over 2, so we flip it upside down and get rid of the minus sign. Now we need to work out c. This isn't super obvious because we don't have a clear point that's on this line. However, we can see that this line cuts through the x-axis. So at the x-axis, we know that y must equal 0 because there's no y-coordinate. So we can use that to work out the x-coordinate. Let's combine these together, and because we need to find the value, the x value, for which this equation has a y value of 0. So replace y with a 0, and we're then going to solve the resulting equation to give us this x coordinate here. Okay, we can take the minus 3 over 2x across to tell me that 3 over 2x equals 6. Then we just solve this equation. We can get rid of all fractions. So 3x is going to be double 6, which is 12. Therefore, x is 4. So we now have a coordinate. We now know that this coordinate here was 4, 0. Now we can find the equation of my line L. So plug in 4, 0 into here. We now have 0 is 2/3 times 4 plus c. 2/3 times 4, you just do the 4 times 2, so that's going to be 8/3. Therefore, we can see that c is going to be minus 8/3. Then combining those together, that will give us the equation for line L. Y equals 2/3 x minus 8/3. So that's part A done. Part B, we want the coordinate of m apparently. And we can see that m here is just the y-intercept for line L. So the y-intercept here was minus 8 over 3. So this coordinate here is just 0 minus 8 over 3. And that's it. That's pretty much all the sort of, well, the more basic ways they can spin questions or actually define stuff to do perpendicular lines. Gets a tiny bit harder than that, but I'll cover that in future videos.